We've seen a lot of the ways that you can use a one-dimensional array in previous videos. So we've seen how to initialize them, how to declare them, and how to do some simple operations with one-dimensional arrays. In this video, I want to do a fairly sophisticated example that involves the weather station data that we have used in a previous video. Now, you may recall that weather station data is quite a large file. It had roughly 10,000 records. Each one is 150 characters long, and each record contains multiple data items. I think there's roughly 11 different items in each record. So let's see if we can take that big data file and let's bring in some of the information into a one-dimensional array, and then we can use the data once it's in the array to just do some manipulations. And we'll use the temperatures like we did before. We'll use the Tmax and Tmin values, and then once we get them into the array, then we can find out the maximum for the Tmin and the maximum for the Tmax. So that's what we're going to do in this example. Now I want to go through this kind of slowly because there's some examples coming up in the future that will continue to use this weather station data. So you probably are going to become quite familiar with it. So let's just go through it from the beginning. At the top of the program, I have declared several variables. Now we're going to read in, the data from the file, so certainly we need to have our IF stream input file. And if we want to, I guess I've got an F stream here. I need an IF stream for that. So we'll have our input file stream, and I'm calling it infile. And this time I am going to make a variable, a string type variable called inFileName. And I'm going to set that to this name right here. Now, the reason that I'm doing this, one, is to just illustrate that you can do this. You can use a string variable when you open a file, but also it makes it easy to change this file name if we want to open up a different file at a later date. And I'm not going to do it here, but you can also prompt the user to type in the file name. Since we have a variable, then we could have a cout statement that says, please enter the file name, and you could type it in and you could save it in a variable. So that's okay too. We've used data line before, so we just have a string type for data line, and we'll use that with our getLine function to read in one line. And as you know, when we read in a string of data, it's a string type, and getLine requires that you read in a string type. So if we want to get the Tmax and Tmin values, then we will use our substring function, and we'll extract the Tmax values and the Tmin values. But when you do substring, you still get a string type. So that's why we have the string type here. Now I want to convert those. So I've also got a double declared for the max and for the min. And I'm going to count the number of records, so I've got an integer for that. But I'm also going to use that first line, that header line out of the data file, and I'm going to use the find operation to find the position within the line for Tmax and the position within a data record for Tmin. So this is stuff I've done before, but I just want to go over it again. Now the thing that's new here is we want to put all the data for the Tmax and Tmin into a couple of arrays. So I want to declare two arrays for the Tmax and the Tmin data. So let's add the code to do that. So I can paste that code in here. And I'm going to make these pretty large arrays, and from prior knowledge, I know that there are less than 3,000 valid Tmax values in that data file. We found that out earlier. And also the same thing for Tmin. So I could make that 10,000, but like I said, I know already that when we filter out those bad data records, I'm left with about 2,700. And it's okay if we have extra space here. So I'm just using my knowledge, and I'm going to estimate that I will not have more than 3,000 of these. So those are pretty big arrays, right? They're pretty big. 3,000 is pretty big. So we have a double, and this is going to be where I store all the my maximum temperature values that I read from the file. I have initialized the entire array to 0 to begin with. And I've got the same thing for the Tmin array. It's a type double, and it's an array of 3,000, and it's initialized to 0. So we're going to open up our data file, and we're going to fill up these two arrays, Tmax and Tmin. And then we'll use those to find out the maximum high temperature and the maximum low temperature. Now, I'm repeating some of the stuff from my previous program. So we're just going to print out our weather station data to the screen, and then we're going to open up our weather data file. Now, I notice here I'm saying that we're opening up the filtered data. Okay, we did that a while back, so we're not going to look at the filtered weather data. We're going to look at the original weather data file here. And if you look, actually, I guess we are going to use the filtered Alabama weather station data. Okay. Let's take that out here and let's go with our original, because I don't want to use the filtered data. So let's fix that so we get the original weather data file. That was my intent, so I'm glad I caught that. So we want to start with the original weather data file. So we've made those small changes there. Now, same process as before. This time when we use our endfile.open, then I'm going to use the endfile name. Okay, so I'm putting that string variable here. So it will open up the file. In my case, I've got it in the data folder, and it's just called Alabama Weather Station.txt as always. So we will use our endfile.open, and we'll use the file name here. And as you know, we should always test to make sure it opens correctly. So I have the if statement there to make sure. So if we do not open it correctly, then we'll just print out the error message. And in this time, since I've got a variable, I'm just going to go ahead and print out the file name. So if we have an error, this will print out error could not open file, and it prints out C:\data Alabama Weather Station.txt. So it's a little bit more informative. And if you're using Windows, Visual Studio on Windows, and you're not using the 2019 version, then you need to have this here so that the output window stays up on the screen, and then we just return, which terminates our program. All right, so if we make it through that, then we're good to go. We'll print out that the file name is open for reading. So we have opened up the file. And recall that the weather station data has, as the first line, it has the column headers. So it's going to have the station name, it's going to have the date, and all that stuff at the column headers at the top. So we're going to use that in order to find exactly which column Tmax and Tmin is. Where do they begin? Where do they begin in that data record that has 150 characters? So that's what this is. We're going to read in the first line. So those are the headers. And I've also added this in. I want to make sure that the length of these is all the same. This is just a little extra thing I put in here. So each time I read in a line of data, I'm going to print out how long it is. It should be 150 characters. So if I run across something that isn't 150, then I'll know that I've got a problem. All right, so I just want to print that out so we can see what the line length is each time. Here is the code that we need when we're looking for the column where Tmax begins. So we use the input string data line. We use the .find method. We look for the string uppercase Tmax. And when we find it, we'll save it as the position of Tmax. So that was the integer value. And once again, being safe and using good programming practices, whenever you do find, you should always test to make sure that it was found. So the test for that is as follows. If the position of Tmax, if it's not equal to string : NPOS. Okay, now again, we're kind of reviewing here. String : NPOS is the largest integer you can store in a 32-bit integer. So that's 4 billion and something. So if our position, if we do not find Tmax anywhere, then the position is returned as a huge number. And in fact, when I pop this up, you can see that the number is 429,496,7295. So if you get that, that means that you did not find the string that you were looking for. But if we do get a position that's correct, then this will be false and we'll skip over. And if it's true, then we'll just print out that the position of Tmax is there, and then we will. So this tests to make sure that we did find what we were looking for. Here we have the error message. If we didn't find it, we'll print out it we didn't find it. And if we did find it, we'll print out the column where we did find it. Now, let's search for Tmin. So we're still using data line. That first line, we're still using it. Now we're going to look for the substring Tmin, and we'll do the same thing. Okay, if we find it, we'll print out the column where we found it, and if we didn't, we'll print out an error message and we'll just terminate the program with this return here. Now, if we've gotten through the first line and we've determined the positions for the two columns, then we're ready to proceed. The second line of data, again, recalling that it's just a bunch of underscores or dashes that goes beneath the column headers, it isn't data. Okay, so we can just read that, and then we can discard it or just ignore it because now we want to get down to the first line of data. And I'm keeping this cout statement. The length of the data line is in here. So I'm going to keep that for the data records that I do read. Okay, now we're getting down to the really useful stuff now. We want to get the first line of data. Then we have a while loop. So we want to fill in the code inside the while loop so that we can extract tmax and tmin and store them into the two arrays that we have set up at the top. And we'll count how many good records that we had. Okay, so then we'll do something else down here when we finish all that. So now let's add the code so that we can read a line of data and process it. So let's paste in the line. Here we do a get line, and this will read from the end file our first line of data. Now we will enter the while loop and we'll begin to process that data. So let's look at the code that goes here. So let's paste the code in and let's examine it. So once again, we're using those substring methods that we talked about earlier. So we have the data line, and we'll use our substring, and we have the position of the tmax column. And again, by looking at the data file, we know that it occupies 5 characters. So we'll just extract 5 characters from the position of tmax, and we'll save it in our string variable, s_tmax. So that's still a string type. And we'll do the same thing for the tmin value, and we'll save it here in the s_tmin variable. So those two things are strings. Now, if we want to convert those to numbers, then we need to add some code to do that. So let's go ahead and add the code so we can do a couple of things here. We don't want to convert it if it's not a valid number. So we need to test to see if it's that -9999, and then if it is not, we'll convert it to from Celsius to Fahrenheit. So let's look at the if statement first. So if we look at the if statement, it's going to test to see if we have a good data record or not. So I'm just going to back this up a little bit. s_tmax, that's a string. And I could have converted it to an integer or another type and tested it. But now I'm just looking for the bad data records, and I can treat those as strings as well. All right, so if the string that's tmax, if that's not equal to the -9999, and if the string for tmin is not equal to the string -9999, then we have a good record. Okay, so if both of them are good data items, then we have a good data record, and we'll enter inside this if statement. So once we get in here, we want to save the temperatures into the arrays, and we want to convert them from Celsius to Fahrenheit. So we want to do that inside our if statement. Okay, so let's back that up a little bit as well. All right, now let's go get the code to do that. So here's the code that will do our transition, or our translation, I should say, from a string type to a type double. All right, now what's going on with these two lines of code? I'm going to use the two arrays, okay, the tmax array and the tmin array. Where's records? Where did that come from? Well, let's scroll back up, and I have declared records to be my index into the array, and I'm starting that out with 0. Now, the arrays are declared again here. Here's just tmax, and here's tmin, and they're type double. Okay, so we need to convert those strings to the type double. So let's move down to the code and look at that. So each time we go through our loop, our while loop, then records is going to be incremented 0, 1, 2, 3, 4, 5, and so on. So we'll add that in. We have our string, tmax, and we want to convert that to a double. So S to D, that's string to double. So it takes the argument that you have here, which must be a string, and then it converts that to a type double. Then we save the result into this particular element of the double array tmax. Now, We do the same thing with tmin. Great. Now, what's this divided by 10? What is this? Why do we need it? All right, well, let's look at the weather data again. So I'm going to bring in that data file. Okay, so here's the data file, and you can see when we're starting at the very beginning, we have bad data records because they're marked with this negative 99.99. So let's scroll down to find some good temperature data. Now here's Tmax. That's a good data read, a good reading, and same here. So all of these are good. They're not marked by the negative 99.99, but if you think about this a little bit, if we're talking about March and we're talking about Alabama, then 83 degrees, well, it's possible, but that's pretty warm. And in addition to that, these are Celsius degrees, so that would make it really hot. And the way this data file is organized is that these are in tenths of a degree Celsius. Okay, so 82 is really 8.2 degrees Celsius. 65, that's actually 6.5 degrees Celsius. All right, so if you read the description of the data file, then you'll find that information. And of course, I didn't provide that, but I'm explaining it to you here, so I don't need to provide that. Okay, move this out of the way. So now that's why I'm dividing this by 10 over here. So this will take our string for Tmax, convert it to double, and then divide by 10. Divide by 10. That will take the string for tmin, convert it to double, divide by 10, and then we store that into here. Well, that's still not Fahrenheit, is it? And I could have done the conversion to Fahrenheit on these lines as well, but I just wanted to separate those out so that we didn't do too much on one line. So if we want these in Fahrenheit, we have to convert them now to Fahrenheit. So here's a couple of lines of code to do that. So let's paste those in. And it says now convert to Fahrenheit. So what this is doing, each line, we're taking our existing number, which is now I type double. So we're going to take that number and we're going to multiply it by 9/5 and add 32. So that converts the number that's in here as Celsius, it converts it to Fahrenheit. So we just take the Celsius values and we change them to Fahrenheit, and then we replace the values of Celsius in the array with Fahrenheit values. So that's what we've done. All right, so that's pulling the data from each record, converting it to Fahrenheit, saving it into the arrays. Now the last thing we need to do here is we need to update the index records. We need to do that, so let's add that. Okay, so we update records, and now we're at the end of the if statement. Okay, so let's close that up a little bit. So here's the if statement, but we're still inside the loop. So we are processing one record. So we read the first data record here. We have gone through the while loop processing it. Now we're finished, but we need to go get the next one, the next record. So we need to do another get line before we exit the loop. So we'll paste that here. And this gets the next data line. Now we're at the end of the loop. So we go back to the top of the loop and we process the second record and on and on and on until we get to the end of the file. So you can see here with this if statement, we filter out all of the bad data records and we store all of the good temperatures into a couple of arrays, Tmax and Tmin. And when we're all done with that, we can print out how many good records we found, and we can close the file because we don't need the file open anymore. Once we've done that, we've filled up our two arrays, our two single-dimension arrays with a bunch of temperature values that are of type double. Okay, now let's use that information. Let's use those two arrays, and let's call a function to find the maximum value and the minimum value. Now what I mean by that is, we have our max, which is the high temperature for the day, so let's find the hottest one. And we have the minimum temperature for the day as well, our nighttime temperatures. So we'll find the warmest night temperature as well, right? And I think that's what I'm doing. I might be looking at something different. If I do, I will correct myself when we get there. All right, now let's go write a function to find the max and min values. So that will go down here where the functions live. Okay, so now let's write a function to determine the max and min, and we'll pass in the two arrays. So here's a start. Here is the type of the function, which I'm going to make it a type void. I'm going to call this find max and min. and I'm going to pass in two one-dimensional arrays. So remember, when you're passing a one-dimensional array to a function, then you must have a formal argument that's the same type, and you can name it what you want in here, but it has the empty double square brackets. So I'm going to pass in the tmax array. I'm going to pass in the tmin array. I'm going to pass in how many elements there are, and the function is going to calculate the maximum value and the minimum value. It's going to return both of those using a call by reference. Okay, so we have our little ampersand here, and we have the ampersand here. So the function will determine these two numbers, and it will return those two numbers to the calling routine, which is main, through the argument list. So that's how we get the data back to the main program. I've already put the return statement here, and because it's a void function, we have to put just a semicolon there. All right, now what's the body of the function? What kind of code do we need in order to determine these maximum and minimum values? Well, we need to start by initializing our maximum and minimum values. So I'm going to paste that in. And my maximum value, I'm going to set that to the first element of the tmax array. So whatever that temperature is, then I'm going to set that as my starting value for max. And for the minimum value, I'm going to set that to the first element of the tmin array. Now these are already declared. Okay, minimum value, maximum value, I didn't have to declare them as integer or floats or doubles in here because they're already declared up there. When you have variables that are in your formal argument list, then those are local to the function. All right, so here's where I'm declaring them. Double here, and max val and min val. All right, here is where I initialize them. So I initialize them to the first element of the array that comes in for tmax and tmin. So that gets us going. So what I'm really doing here, now I can see, is I'm going to get the maximum temperature for the tmax values, and I'm going to get the minimum value for the nighttime temperatures. Okay, so this will give me the lowest nighttime temperature and the highest daytime temperature when I'm finished. Now we need to go through and we need to check every element in these arrays to determine if we need to reset max val and min val. So let's add the code to do that. So let's paste in a loop. And here's the loop. Now I didn't declare k up here anywhere. I can declare it here as part of my for loop. So for integer k equals 1 up to the number of elements minus 1, k plus plus, I'm going to go through. Now I'm starting k at 1 because I've already set the 0 index up here. Okay, so it doesn't hurt to redo it at 0, but since I've already taken care of the 0 index, I don't need to start there again. Okay, so k's 1 goes up to the number of elements minus 1. And here's our simple if statement. So if the current maximum temperature is greater than the max val that we're holding, then we just reset the max val to whatever that tmax value is. So this will go through every temperature in the array, and it will find the maximum value, and when we're all finished, max val will contain that maximum value. Now, for the minimum values, if we're looking at the tmin, those nighttime temperatures, the lows, then if we find one that's lower than min val, then we just reset the minimum value to that particular temperature. So when we're done here, we have the lowest nighttime temperature for the entire month, and that's because the data that we have only goes through March of 2018. So we'll be passing in these two arrays, and they'll be pretty large arrays, as you can tell. They're going to be 3,000 in size. All right, well then, once we are done with that, we have the return statement, and then we terminate the function. So the minimum value, maximum value, those go back as call by reference as parameters in the function. To finish our function, we need the prototype. So let's copy the first line, and let's paste the prototype up here. So that goes up here. And we just put a semicolon afterwards because prototypes require a semicolon. Then we can just call the function down here. Okay, call the function to find the maximum and minimum temperatures. So let's just paste in the call to that, to the function. So that goes here. And let's take out some white space. So now we call the function. We want to pass in the maximum temperature array and the minimum temperature array. So we just use the names of those arrays, and you do not use the square brackets. So we just pass in Tmax, we pass in Tmin. The function also requires how many records we have, and we found out how many records up here. Okay, so when we went through the while loop and we found a good record, we counted it. So that's how many good records we have. So we'll send that in. Now, the max and the min, okay, those come back from the function. Those are returned. So if I look in my main program, I've declared max and min up here just to be 0 and 0. Okay, so the function will fill in those actual values when it returns. So afterwards, after we call the function, sorry about all the scrolling, after we call the function, then we'll have values for max, min. Then we want to print those out. So we want to print out the max temperature is and the minimum temperature is. Well, I'm printing out variables here. I'm printing out data that's a type double. So if I want to format it, then I need to use my output manipulators. So before I print those, I want to set fixed, and I want to set a precision of 2 so I don't get 6 digits to the right of the decimal here. Then we'll print those numbers out, and that's the end of the program. Alrighty, well, now we've written the program. Let's compile it and run the program and look at the output. Now let's bring in the output. All right, so here's the output. And I need to show you something because I did make a mistake earlier. And I wasn't recording at the time, but I had to make a mod to the program, which I will go show you here shortly. But notice that I was wrong in my count. All right, so there's actually 3,173 good data records, and I only allowed for 3,000. So I had to go back and change the code to make those arrays bigger because the program aborted because it didn't have enough room for this. So that was a mistake. That's going to happen. You're going to make mistakes, a lot of them. So it's good to be able to discover the mistakes and be able to fix them. All right, so now let's go back and look at what I did to the code so that this would not abort. Okay, so if you scroll back up to the top of the code, then you'll find that I declared these arrays to be 3,000. I ran the program and it aborted because there were more than 3,000 records. So I just went back and I changed it to 4,000 so that I would guess again and see if I was okay. So it turns out that there are less than 4,000 data records. All right, so now let's compile and run the program again. We'll bring in the output again, and it's the same thing I just showed you, but I wanted to go back and tell you about that error that I made. So here we go. So just tracking it, we look at the stuff we print to the screen to make sure we got the file open okay. And then I'm printing out the record length, and you know, I could have put that inside the loop, but if I print out the length of the data record for every single one of those data records, I'm going to have that printed to the screen 3,000 times. So I did not print that out inside the loop. Okay, then we get the first line of data before the loop, and we continue to go through the while loop until we get to the end. And we end up with 3,173 good data records for Tmax and Tmin. Now, as we're going through the while loop, we are adding all of those to the array, the two one-dimensional arrays that I show you down here. So we're filling up the arrays Tmax and Tmin. Once they're filled up, we exit the loop that's reading the file. Then we want to call a function to find the max and min. So I bring that back over, and we see that that now does work. And the maximum temperature, the hottest daytime value, was 47.48, and that now is in Fahrenheit degrees. And then the minimum, the lowest nighttime temperature in the Tmin column is 35.60 degrees, which makes perfect sense for March in Alabama. So there you have it. There's an example of an application where we're using a one-dimensional array in order to hold a large amount of data. Now, just finding Tmax and Tmin, that's probably not going to be very satisfactory. In the case of this data file, you would like to know, perhaps, well, if we measured this temperature, if it was 47.48, then we don't know what day of the month that was, and we don't know what weather station measured that. So to make this more useful, we would also need to print out, the name of the station and the date, but we didn't save that information anywhere. If you want to, you can store all of the data, all 150 columns, by making additional arrays up here. So we could have tmax and tmin. Then you could make another array that has the integer values for the dates. You could put in another array that has the names of the stations. And if you want the other data columns like precipitation or something else, you can add arrays for those as well. So we can have as many of these one-dimensional arrays as you want to. And this example is just to illustrate the process. So now, and if you have an application or a problem where you need to know the station name, the precipitation, the date, and etc., then you could just use this kind of as a template, and you could add that information into the program, and you could save that data as well. All right, well, that completes this particular example, so we will stop the video here.